think most of you are here this morning. Just to check with you, I think we should be starting on the, I think you're the last group to start on the tutorial number 5. Am I correct? Right. So can you just pull out your tutorial and we will get started. Now, before I jump into the tutorial number 5, are there any questions from the previous tutorial? I suppose you all can hear me. Yeah. Is it how's the sound level? Okay, loud enough?
Loud enough, loud and clear.
Okay, good. Thank you, Chung Yi. So today we will start on the tutorial number 5. At the same time, can you maybe just prepare yourself? Put up your lecture notes if you have nearby. And also maybe some of you take out your calculator because I will be inviting some of you to join in there answering the questions. So any requests for the questions here? No? Okay, I'll get started. Now this one is on the basically on this tutorial is related to the lectures on the introduction to neural networks. So we'll look at the few things here. I can get my system up. Okay. Now the first question is draw the figure. So this one is very simple. Hang on. I think my my board, digital board, actually just went dead, and now I think it's coming back. I think because of the connection. Okay, now I think it's okay. Okay, right. So this one is draw the now. If you ask you to draw the figure of a typical biological neuron, right? So this is a very straightforward question, but of course, depending on the situation. So this one I think is this one for tutorial is straightforward. You just draw. But in the exam, if this one is some same question comes up, you will have to do more than that because you have to draw and then label the parts of your biological neuron. So this one we'll leave it for the time being. Maybe if you can, right? Maybe I'll just draw it here. My drawing is very bad, but you have something like this. This one doesn't work. Okay, it's a bit lagging. Even this is lagging. So you have your coming from the other neurons, right? So this one comes here. So you can see here, and then of course here will be something here, the blob here. Remember, we talked about this. So this is will be your typical. This is one neuron. Of course, this is other neurons. So this is your basically your image of your neuron itself, the biological neuron, not the artificial ones. Let me see if I can just show this. Okay. I can just erase this. So that is your question number 1. Okay, now this is better. So I don't have to. I can see my command window out there, the tools. Oh, I think I moved the thing again. Okay. Oh dear. This one is not working again. Sorry for the technical problem. Okay, good. That's why I was wanted to. I think I make a mistake the last time. So I think who was it? Let me see. Wait. Thank you. Who was it? Xin Xian. Thank you. How about tutor number 4? Which I think because of the I mixed up with the because there was a replacement class. I think we have not done. You guys have not done the tutorial number 4. Am I correct? Okay. This is good. At least someone highlighted to me. Thank you. So let me go to tutorial number 4. Okay. This one is so can you pull out your tutorial number 4? I'll shut this down because according to my records, I checked yesterday. It seems that I may have missed up the tutorial number 4. So this one, have you done this? According to my records, I think probably not. Correct? Before I jump into it, Xinxian, 4. Is this familiar? Okay, because I mixed up because of the replacement class, right? I thought you guys would do so. It's okay. That's why I couldn't my records. I was sort of waiting for you guys to confirm this. So let me shut this folder down. This one I need to shut this folder down. Okay. Okay, right. Okay, now this one is this one is actually it takes a longer time. It's basically all calculations. Okay. Now we have this what do you call it, the fuzzy expert system that we have built. Now for this expert system, it consists of 2 inputs and then there's only 1 output, right? And then there are only 3 rules here. You have your rule number 1. Let me see if I can get my system up. My pen is not working. Okay, now it's working. So you have a rule number 1, a rule number 2, rule number 3. Now, for rule number 1, so you have, let's look at the inputs. You have an input X. Now, how do I draw? Maybe I draw it this way. You have your X, and then your Y, and then your Z is your output. Okay? So you have your X has 3 memberships classes. You have your marginal. Now Y is low. So if your X is marginal or your Y is low, then your Z is also low. Now rule number 2, if your X is also marginal, right? So we have 1 here. This is rule number 1. No, I don't think we need to put it rule number 1. Just say that this is X is marginal, and then your Y is high, right? And then Z is normal. And I think this question will be quite simple for most of you because this one is actually a simple case of compared to your assignment. Now the last one is if X is low and your Z is high. So you can see here, my X and Y have only 2 membership classes, and then my Z has 3. So as shown on the next page. So you can see here. Maybe I'll do it this way. Oops, sorry. Okay, Z. Same here. Okay, done. So I have 3. So you can see here. Okay. Now my X is marginal and low. So but you're given actually 3 memberships here, right? For your X input X, low marginal, but the rules only use two of them. So the last class is not used. The third membership high is not used. But anyway, you are given that membership. Okay. Now as for Y, we have a low and high for these three rules here, right? But it's fine, right? You have low and high. And for Z is three classes, low, high, normal, and high. That is your background, right? So now you're asked to determine what should be my output, the Cripps value. Value for Z when your X is 91,000 and your Y is 34, right? So what's the next step? What should I do next? What do you think I should do next? Maybe some of you can try. If not, I will invite some of you. Yan Chang, want to try? What should I do next? What is the Wei Hong's line drop again? Yan Chang, are you there? What do you think? What do you think I should do next? What's the first thing I should do? Yan Chang not here, is it? Yi Chi, is it? Yi Chi, Teo Yi Chi. See the graph. See the graph. Okay. What do you mean by see the graph, right? So so the first step will be what? Look at the graph, right? Look at the graph. Which we have four graphs here, right? So which graph should I look at? Right. So the clue is you are given 91,034. So let's look at this. Your X and Y. So let's look at X first. This is your X. So X is given 91,000. Your input is 91,000. Let's try to draw this now. Maybe not. Go back here. 91,000 will be somewhere over here. Right. So again, these kind of questions is better to actually transfer this plot into a proper piece of graph paper. Right? Because here we are just for this morning's tutorial. Of course, I don't have a graph paper to show it to you, but of course, in the when you actually want to try this out, you should actually transfer this into a graph paper, right? So you can see here, this is my points here. So probably this is my point here and one point here, right? So this is my 91,000, right? So this is 91,000. Now, so Yan Chang is correct. So now what's the next step? Next step after doing X, and now I do Y. Y is 34. So I do the same thing. 34 will be somewhere here, right? 34 will be here. 4, 6, so it's here. Okay, so what's so good? Any questions? So I got that. Now, next step, what do you think I should do? Who else? Who else want to try? Chu Wen, is it? Pang Chu Wen. Shu Wen. What should I do next? After I got all my, as Yang Chang suggested, I have now look at the graph, and then I plot the line, I show the line. So what should I do next? Shu Wen? Add up. Add up. Not really. Not really. Anyone else? Kasing, what do you think? What should I do next? As I said, not really. You don't add up the, as I understand. Yeah, correct. So which one? Okay, Kasing. Okay, good. I think you roughly understand the concept, the idea behind that. Of course, as I said many times, I think I also maybe fed up idea. If you don't know, please ask, because I can only guess what you know and what you don't know, right? Unless you ask, that's why you should try to also participate during the classes. And I think this one's saying it already, isn't it? Is it? No, I think it's okay. So now you look at go back to your rules. Now, of course, I think as Casing suggested, and we need to get the probability, not probability, it's actually membership. The membership for X, membership for Y, and things like that. So let's look at it. Now, I only interested in the membership for X when it's marginal. That's for this particular uh, first rule, right? I'm looking at the first rule to look at this. So okay, now so maybe I ask a simple question. Let me try. Let me see who else is there. Leong Ho, simple question. What is my for X equals to 91,000? What is the membership for high when X is 91,000? Leong Ho? Correct. Good. Right. So in a way, it's a trick question. I just want to make sure you guys know. So the memberships here, if we look at it closely, there are 3 points here actually. There are 3 intersection points. First of all, I don't know if I may draw this. So this all goes all the way down, and then actually it's somewhere down here. So there's a 1 point here. Normally we don't consider it because it's 0, right? 0. So we normally we do not discuss this, right? So now for the first rule, if X is marginal, so X is marginal. If X is 91,000, so we try to find out what is the intersection point for when when X is marginal. So we can maybe, oops, sorry, draw it here. Let me just draw it there. And then move it down. Right, so this is my intersection point for marginal. So what is the answer here? Siapa lagi? Leong Ho. Okay, Maylin. What is my membership for X is marginal when X is 91,000 for marginal? 0.1. Betul tak? Let me check. Sorry. Oh, sorry. Yeah, correct. So it's about 0.1. So this they say this is 0.1. Okay, so far so good. Now, then of course we have this, and then we go back to our question. Oh, sorry. What is this? So we put it down here. So we have your 0.1, right? And also we notice that rule number 2 also uses the same value, marginal, uses the look at also marginal the membership. So we can also put it down here. Now, since we are doing X, I must well do the rule number 3 as well. X is low. What is the intersection for membership for low? So again, we can do it here to the line. Okay, and then we look at low. Here, isn't it? Low will be here. Okay, let's see. Let's see anyone awake or not. Wei Hong, your line this morning is not very good. I can see you coming in, dropping, and then coming back again. Good. At least you are paid. At least you try to come back when your line drops. Okay, what is the membership for X for low? Yeah, I think it's okay. But you can see the difficulty here we have because this is based on our estimation because we don't have a proper graph paper. So this one, let's assume this is correct. So you can see the answer may not be very accurate. But for this tutorial, I think we make sure that the graphs are simple, so you can actually estimate. And okay, so if you ever have such a question, please don't do it on the piece of paper on the question paper. Try to do it on the what do you call it, on the graph paper. So we have 2 now. So 0.35. Now let's go back to X 0.35. Now X is low. Okay, so it's down here. So your 0.35. Now we look at Y. So Y is low and high. Now we look at the first one. Okay, So this one is very straightforward. There's only two membership graph here. So we can do it. Let me just draw it here. I can even change the color. Oh, okay. Not so good, isn't it? We can't see clearly. What color do I want? Maybe I can do green color. Maybe do a thicker line. Okay, right. So X is low. So your low will be down here. Okay, so and then another one will be over here. X is high. I draw another line. Sorry, over here. This is a bit not so flat, isn't it? I need to draw it down. Okay, so this is it. So when X is low, pencil. So X is what Y is low will be. Let's say this is 0.1 or so, 0.1. Now what about when when Y is high? It will be, this is say point. What is it? What do you think? Maybe 0.90. Huh? 0.9. Actually, it's a bit out, isn't it? It's not really 0.9. So I will try maybe 0.92. Right? So it's a bit out upper here. Right? So good. Right? So you have all these values here. Now we go back 0.92 and 0.1. Right? Y is 0.92 and 0.1. So you'll have your X is Y is low is 0.1 also. And then when my Y is high is 0.92 now. Right? So far so good. Now I have this. Now what's the next step? What should I do next? I should now try to figure out. I should try to calculate, figure out what is my consequent, the then part. So what's the value for Z now? After Wei Huang, who is it? Wing Liang, Mr. Yong Wing Liang. What is the value for Z now? For the rule number 1. Wing Liang, class is waiting for you. Are you there? That's the first question, isn't it? Otherwise, we're waiting for him, and then he's not there. He maybe step up for the toilet or whatever. Wei Liang, no, not here. Who else? The class is quite small, is it? Wei Liang, Su Wen, maybe I've called you just now, isn't it? Why the class is so small? I only have very few number of students. Jie, what do you think? What do you think is the answer? What is my Z supposed to be for rule number 1? Try. Oh, also I think Jie also cannot hear me, I suppose. Zhongyi, maybe back to you. Okay, morning, Jie. Okay, good. Jie is back. Don't know. Is it? Want to like they say, tembak? Want to just try? So you see, that the whole idea is actually, don't worry. I think the whole idea is for you to learn. So don't feel bad. If you don't know, means I fail. Not your problem. My problem. I fail because I don't know. I have not been able to teach you well enough to communicate well enough. So you see here, I have this rule number 1. The rule number 1 says that if X is marginal or Y is low, then your Z is low. So we figure out the membership of X when X is 91,000. Draw this here. Maybe I change the color to so 91,000, right? And then Y is 34, right? So from there, I know that we figure out the membership for X is marginal is 0.1, and the membership for Y low membership for Y for low membership is zero point 0.1 also, based on the actual value of down here, right? 34 and 91,000. So you have these two, right? And then they are, uh, you might use the word related or combined using the OR function, the union function, or is it a union? The union of the, no, this is intersection. No, the union is correct. Union, all of for the two functions here. So from there, what do you think? Now, TA, can you remember if you were to use the union, what I call membership, what do I do? If I can pull out something here to help you. I don't have it here. How come I don't have it here? That's interesting. Maybe I don't have it at the back, is it? No, is that at the back? Oh, okay. I should be at the back. There you go. Okay, here. If I can zoom up, maybe I can zoom up here. Can you see that union? TA, what do you think? Don't worry if you don't have what I call notes with you. We'll try to walk through the rest of you, so you can follow now. If you're union between A and B, two memberships, you have actually so look at this, right? So you have two of them. So we know that we're trying to get the union of your two memberships. Yes, correct, huh? So what happens if it's let's say what happens if it's this one is let's say 0.12? So what would be the answer? Because both are 0.1, so I mean, it doesn't show anything. So if it's 0.12, what do you think is the answer? Answer will be 0.12. So you take the larger of the two, right? Larger of the two, right? Maximum of the, you compare the two of them, right? So you get your 0.1. So this one, because both of them are, what do you call it? Both of them are the 0.1. So you have your 0.1 as well, right? So this is, Z will be 0.1, right? Low. So let's go down here. Now look at Z now, 0.1, low. So the 0.1 will be here. Right, so this one is your low. See that? It's lower. So this is low. So we have actually done this Z equals to low, 0.1. So now go down to the next one, rule number 2 now. So your rule number 2, same thing. Now, who else? Siapa lagi? Chungyi, simple one for you. What do you think? For the rule number 2, what should be my output for Z? Knowing that this is an intersection. Intersection is your end function. To help you, let's look at the reference, the fuzzy set operators. If it's doing intersection over here, right? Intersection, this is strictly the end function. And then this is obviously your OR function. So what is it? Right, so yeah, correct. Chungyi. So this is 0.1. So this is 0.1. What is it? 0.1 is what? Normal, isn't it? Normal, normal. So you must also look for the right one to actually intersect, right? Because we have now I have 3 memberships here. So again, 0.1. Maybe I can do just a different color to differentiate. So your 0.1. Normal is 0.1, right? So it so happens it's also 0.1. So you can see here different colors. You can see now let's go back to the 0.1. So this is also 0.1. So you can get here because it's you're trying to find the minimum value because of the intersection. The end function here, so it's also 0.1. Oh, sorry, my speaker is getting in the way. All these wires are 0.1. Okay, the last one here. Straightforward, right? If x is low, then your z is high. So this one, nothing much to do. So you just take the 0.35. Any questions so far? Okay, 0.35. Now, where's my 0.35? Again, just to keep it a bit interesting, it is a different color. And what color do I want? Say orange, 0.35. 0.35 will be somewhere here, right? So let's say 0.35 will be somewhere here, right? So now the next step will be, now to help you, I'm now shading the, if you remember, the steps involved in your fuzzy logic estimation. We're trying to find the center of gravity for this shape. Looks something like this, right? Right, so this is I'm trying to find the center of gravity for this particular shape over here. Sorry. Never mind. Okay. Looks like I've accidentally deleted the what I've done. Okay. Remember, we have many methods for determining the center of gravity. So for simplicity, we will not use we just use the clip version to find the center of gravity. Now, what is that? So there will be equals to, if you remember, center of gravity will be to find you your crisp value, to find you the actual value, right? The actual value for the Z, right? We're trying to find the output, right? So we're trying to find the crisp value for Z. Okay, I need to speed up after looking at the time. I think some of you may have other things to do. So let's quickly go through. This one I need your help. I think this one will be, now this will be the summation of my membership for Z multiplied by the actual dz over summation for my membership Z. No, correct, right? Right, so this is multiplication. Now, what does it mean here? It means that I need to sample it, right? I need to find the center of gravity. So what do? I will have to take, let's erase this. Oops, even worse, it deleted. Never mind. 0.1, right? We have 0.1 over here, somewhere, something like this. So over here. Now, so notice here there's an overlap here. So we take the larger value, right? The upper membership here. So so this one actually you can see here the membership multiplied by your sampling points, and then this is divided by my memberships. So let's try a few here. So what's the first one? Let's say we take for maybe for simplicity, convenience, we take 0.02. Our sampling rate is equals to 0.02. That means that each of the lines here, right? So we take the first one here, here, and here. Then multiply by the actual value, which is 0.1. This will be 0.35. The top one here, this is 0.35. Good. So now I didn't take this first one here because if you multiply by 0, right, you'll find that this is actually 0. So there's one value short. right? So will be 0.0. Now first one is 0.02. 0.02 multiplied by 0.1 plus the next one is 0.04. So we take sampling points of 0.02, 0.1. So you can see I can shortcut this. I can do all the way until maybe somewhere here, right? So what I do, so will be to shortcut this, I will get 0.02 plus 0.04 plus 0.06 plus until this is somewhere at 246, 0.76 times by 0.1. Anyone help me with this? Just calculate for me what's the summation here. So we take all the samples here until here. Now the next value here will be this point here. This point here, you can see it goes all the way up. So now plus my, let me just erase this to clear the space here. So this one will be over here, right? This is plus 0.78, right? My next sample after 0.76 multiply by what? Multiply by 0.35 plus, now, then I have 0.78. Then I can do the same thing, which is 0.80 plus 0.82 until 1.00 multiplied by 0.35. That is your numerator, this part. Now, the bottom part here, the denominator is simpler. You just take all these values here. All my memberships 0.02, 0.04, 0.06, and then my 0.78, 80, 82, and so on and so forth. Sorry. My mistake. It's not the exact. The bottom here is actually the membership, 0.1. So you have your 1, 2, 3. Let's say, so it's 5, isn't it? 5 per block here. So it's 1, 2, 3, 4, 5, 6, 7. 7 times 5, 35, 36, 37, 38. So you have your, this one will be 38 times 0.01, right? Membership is 1.1, right? Plus, now 0.78 is what? 0.7 is over here. 1, then you have your 5 and 10, 11, correct? 0.0, sorry, point, what is it? 0.35. Clear? 0.35 because I'm actually summing up all my memberships. So, I take 0.1, 0.1 here, every sampling point, sum up until here, and then I move to 0.35. Maybe guessing, okay, now what's your question? 38 times 0.1 or 38 times 0.1? Now, good question. I think I can see your confusion. Why is that? Because you see, if I may say, can I erase this? Erase this. No, maybe not. It's very messy, my chart here. Now, you see that what we did here was that we actually sampled at 0.02, isn't it? That's our sampling point. So this is my 0.02, 0.04, 6, 8, 10. Right? So what's my membership here? This membership is actually 0.1. This is my after the rules here. Right? So you can see here, the first one is 0.1. Right? That's why we have this 0.35. Is it clear? Now, maybe it's good for me to ask you, how do you arrive at 0.01? Maybe I missed something there. Well, how do you get 0.01? Because you see our membership for Z is actually 0.1, right? Because based on this either the union or the intersection. Is it clear? Oh, typo. Good, 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 good. At least, at least I know what was the confusion. Correct, correct, correct. So this morning, my brain and my hands are not in sync. Thank you. Right? Good. Now this I'm clear. 38 times 0.1. So this will be what? 38 times 0.1 will be 3.8, right? 3.8 plus my. Now this one is actually, can someone help me with this? 0.35 times 11. So you have your 3553, 3.85, isn't it? 3.85. Is it correct? Right. 3.85. Good. So add up together, what do you get? Now, can you all try this? I think I have no time already, so I have no choice. But this will give you. Let me check my answer. Let me see my answer. What do I have? I think the answer is a 3.6 something. 7.65. Is it? Okay. But no. Yan Chang, I want the other answer. I want this, the center of gravity. So this is 7.65, correct? So this one you have your. If I can erase this. So what I have here is actually you have this. This is 7.65. Okay, good. Han Xiang, thank you. There's some value here, and this will give you 0.682. Is it correct? Right. So it's around there. So 682.62. You can see now the 682 is somewhere over here. 682. Somewhere. This is 0.7. So it's somewhere here, isn't it? So this is your value. So it looks all right. Why? Because you look at you look at it from the point of view of your balancing, the point where it balances the two parts of your left and right of your membership, right? Of that Z memberships. You find that actually it's 0.6. So there's a what do you call it, a quick way of see whether the answer is right or wrong, right? Let me see. What do I have? I have. I got okay, mine is a bit different. So it's about actually it's 0.63, around there, 0.63 or 0.65. So it's not too bad, right? 0.62 is not too bad. Now, this is using my what? I've not, this one is what? Using Mandani or using Sugano. So what we have done so far is using the Mandani method. So now let's look at Sugano. So look at Sugano for here. So this is your output. So for the first one, it's 0.1. Oh, my line is dead again. Okay, so this is 0.1. This is also 0.1. The last one is 0.35, somewhere here. Okay, so what do you have? You still want to calculate the answer. So what we have here, 0.1 multiplied by this value here, 0.1503. This one is 0.1 multiplied by 550, right? 5500, and this is 0.35 multiplied by 0.8971. Now this one again, you use the same formula. That's your dz. In this case, this is your z value here divided by your membership. Now, can someone tell us what's the answer here? So you have this one, multiply, add them together, divided by, this is what? Divided by what? This is 0.1, 0.2, 0.55, right? So what's the answer? 68679. Right? You get this? No, maybe not. Maybe. So I was using a different value. So I'll wait for you all to help me to calculate this. Now, maybe 6982. 6982. Thank you. And so is 0.6982. Now, how? Okay, which one do you think is more reliable? Which answer is more correct? Right? You can see that Mandani should be better because it's based on the actual graph itself. But this one, this one is an estimation. So can you see the advantage? Right? We've taken so long just to calculate the answer for this. But this one actually able to give you answer, which is 6902, 6982. Whereas the one is what 682. But so it's not too bad. But this one is much faster, right? So I think I'll quickly move on to the next question. Now, any question before I move on? Right? So I hope you can understand and try it. So this one here have two fuzzy sets, M and N, right? So basically, these numbers here says that it's not dividing. It just says that the first element, right, second element, third element, fourth element, and the fifth element have these memberships: 0.33, 0.67, 1.0, 0.67, 0.33. The same goes for your N. Now, if I want to find the union of my M and N, right? M and N will be, what's union? Union will be the maximum value, right? So again, this chart will be given in the exam if such a question comes up, so for you to refer to, right? So union will be maximum, right? So you compare the two, right? So the answer will be, first one will be 0.33, first one. Second one will be 0.67 because you compare the two, and then you have your 1.0, 0.67 again, right? This is answer here. 4, and then lastly 0.33. This one, right? Now I'll skip the rest. You can try later on when you're free because of the time factor. Now, second one, there's another way of representing the fuzzy sets. So in this case, you have A, B, and C. This one is represented in a different way. It's inside a bracket. So if I were to draw back the same memberships for the sets here, I'll have this, and this one starts from 0, 0.3, 1, 0.5 for A, over 2, 1.0 over 3, then 0.7 over 4. The last one is 0.2 over 5. Right, so it's a different representation, different way to represent, right, the fuzzy sets, the membership of the fuzzy sets. Just wait this, give me some space. Now, first one is we want to do this. This one A and B. Let's look at this one here. My board is not very lagging a bit. This is my bounded sum. Maybe where did it go? I think it's missing. I can't zoom in. My little cursor is gone. Oh, damn it. So this one, anyway, trust me, this one is actually bounded sum. Now, bounded sum, what does it mean? You take the minimum of this, right? So you compare the summation of the two membership A and B, compare against 1. So it will be always less than 1, right? Because always less than 1. So you have to prove that A and B, bounded sum A and B equals to the same as bounded sum of C and D, right? And then obviously you can look at it, this will never be true unless your C equals to B. So let's try the first one, A bounded sum with B. So you have to add up, first of all, add up A and membership for A and B. Mu A plus mu B. right? So the first one will be 0.1, right? Add up these two. This is 0.5 over 2. This is over, sorry, this is over 0. This is, should be over 1. Next one is 1.5 over 2, 2.0 over 3, 0.94, and the last one is 0.25. Right? So this is what you get. Now, when you perform the operation, the bounded sum operation here, you compare against 1. This summation against 1. So what you get? A bounded sum of B will be, you compare and you take the smaller value, right? So you can never exceed 1. So this will be 0.1 over 0, 0.5 over 1, and the next one is 1.5, right? 1.5 will be, bounded by, so you cannot exceed 1.0. 0.9. For the last one is 0.25. Follow? Okay, I have 3 minutes left. So I will now, so you try the next one, where you have a bounded sum for CNA. So you add up the membership for CNA, right? CNA. So and then you do the operation of your bounded sum. Now, bounded product here, the next one here, this question, bounded product. Now, what is it? You do the same thing, except that you have to also, now bounded product is actually mu A plus mu B minus 1 compared against 0. You take the maximum one. So here, first of all, you do your bounded, what do you call it, this operation, minus 1.0, right, minus 1.0, and you take the larger value. Product, minus 1 and 0. So the compared to 0. So it can never be less than 0, right? So this one minus 1. So you get your first one will be minus 0.9 over 0, minus 0.5 over 1. The first one here, 0.5 over 2, 1.0 over 3, the fourth element, and then minus 0.1 over 4. And lastly, this is minus 0.8 over 5. Okay, any questions? So now I want to do the operation, the bounded product of A and B. So what I do, I compare these values here against 0. So, and I take a larger value. So the first answer will be 0.0 because you compare the minus 0.9 over with 0. Of course, 0 is larger. So you can see here, the bounded product will ensure that you will not have a negative value. Zero over 3. And the fourth value here will be again 0.0 because when we compare minus 0.1 with 0, you get 0. And the last one, of course, will be also 0.0 over 5. So it's straightforward. So again, you can try it. Now, obviously, even without trying, you know that if I swap this around, so this one has doesn't matter which one comes first, right? So basically, it should be the same. Answer should be true. It will be false. Right, this one, it depends. This one, again, does it matter which one comes first? So you first of all, you do this part here inside the bracket first, and then you take the answer here. You do a union with C, and after this, you do a union with A and see what's the difference. This one, I can tell you answer is true, right? So it's the same. Now the last two ones, last part. Okay, quickly. I'm running out of time. If we can spend 1 minute, I will just do the last one here. Now drastic sum and drastic product. Now, drastic sum, drastic product, actually, look at it here. Now, how do you read this? So basically, you look at, you first of all, look at the B, membership for B. Is it 0? Is 0, you take the value for A. Now, do the same thing for A now. if membership for A is 0, take the membership for B. And then otherwise, if none of this is true, you take 1. Let's try this out. And then I'll let you try now for the drastic product. When you try it later on, instead of looking for zeros, membership for 0, you take membership for 1. And then if none of them is 1, you take 0. Let's try the first one, drastic sum, which is here, 0, 0, 1. So you take, now you can erase it here. Give me a minute. I should be finishing very fast. Right, first one here. Now, you look for A and B. So first one is, now if this is, so we look for 0. So in this case, look for 0. So the first one will be, so I take B. Look at A is 0, I take B, right? Now next one here will be, if any one of them is 0, right? If none of them are 0, you take a 1. So this will be 1.0 over 1. This one, third one, anyone 0? No, right? So you put down here. Now this one, 3, same thing, no, none of them. Fourth one, no. So 1.0. The last one is, last one, B is 0, so you take A. It's very simple. Okay. So you're supposed to prove, no, you're supposed to only calculate this for this now. Now for drastic product is you look for 1 and then 0. And neither of them is 1, right? So for drastic product will be here. Look for 1. So here, if I can just hang on, you just be patient for a while. So look for 1. If not, you put a 0, right? So anyone A and B is 1? No. So you put a 0. Then anyone a 1? No. 0.0 over 1. This one is a 1 now. The 1 you get 0.5. Now B is 1. And so you take the membership for A. This one is both are 1, so it doesn't matter. You take either one, right? And 4 here, no. Last one also no. Right, so this is answer for the last part, part E. Right, so you look for 1. If both of them not 1, 0. If we take one, one of them is 1, we take the other membership value. Okay, so I think we stop here. I think some of you may have classes to go or your FYP 1 presentation. So those of you who want to leave can go off now. Otherwise, if any questions, I'll welcome any questions from any of you. If not, I'll see you tomorrow morning for the class, for the lecture. Okay. So rest of you, bye-bye. Anyone with any questions, please feel free to ask me.
Hello, good morning, everyone. Can you hear me?